So in yesterday's lesson, we learned about slope and how to calculate slope by looking at a graph of a line. We also discussed briefly how what the slope really of a line really measures is its rate of change, and so we're going to expand upon that today. We covered the fact that you can calculate the slope by looking at the rise and the run as well. So I would encourage you, if you haven't yet seen the video on calculating slope, that you begin with that video. But I want to expand upon this formula. I'm going to quickly just draw a set of axes. So I have my vertical or my y-axis, and I also have my horizontal axis. And if I had a line going through this, so let's just say a line, I can pick any 2 points along that line, but usually the grid marks are really nice ones to pick. And I can use that to calculate my rise, which is my change in my y value. And I can use my run, which is the change in my x value, right? So in math, we use this little symbol called delta. It's like a triangle to mean change in. So the change in y compared to the change in x. Okay, so again, that little delta sign there, it's pronounced delta, but it really means change in. Right, so I can really just rewrite this formula for slope as the change in my y compared to the change in my x values. So let's apply that to a real example. So I'm going to go ahead and calculate the slope of this particular line. I'm going to use some super easy points here. I'm going to use the point 0, 0, my origin, and I'm going to use this point right here. And I'm going to use those two points to create my slope triangle. And I can see here that the change in my x value is 1. So there's my run. And I can see that the change in my x value, well, each tick mark represents an increase of 15, so that's 15, right? And so I can go ahead and I can calculate slope. Remember that the symbol we use for slope is m. And so I'm going to take my rise and divide that by my run. And so just numerically, that gives me 15 divided by 1, or simply 15. So there I've calculated my slope. But now I want to know, well, what does that mean? So let's take a look at the graph. The graph title says Ethan's earnings, right? And so if I look at my labels, I'm looking to see how much money he makes in a certain amount of time, right? And so let's look at that. Well, my money divided by my time, what do we call that? The amount of money that we make per unit time, per hour? Well, that's really just our wages, right? So this 15 that we have right here really means that he's making $15 per 1 hour or per hour. So there, we've interpreted what that slope means. And I can see that the slope is consistent. So if I had picked 2 different points, I would get the same slope triangle, no matter where I go. So it looks to me like he's earning $15 an hour for the entire time that he works, wherever he's working. So I want you to take a look at this graph. Pause the video, take a look at it, and try to interpret what the meaning is of the slope in this case. All right, I'm going to go through and solve this. Hopefully you've paused the video and taken the time to figure out what's going on here. So if I just calculate the slope straight up, I know that my slope is always equal to my rise divided by my run. Right? And so I'm going to pick 2 points, whichever points seem the easiest. In this case, I'm going to again pick 0, 0, but I didn't need to. I can see that it's has a positive slope. It's increasing, so my slope will be a positive value. I'm going to draw my little slope triangle. So it looks like my rise right here, I'm going from 0 to 150,000. And my run is 1,000. So just straight up calculating slope here, I'm going to end up with my rise of 150,000 divided by my run of 1,000. And that gives me, looks like if I cross out my zeros, 150. So my slope is 150. And so now I want to interpret it. So I'm going to look at my labels. So it looks like I'm measuring cost of building a house versus the square feet, right? And it looks like it's a pretty constant value here. So really, if I'm looking at my rise over my run, I'm looking at the cost divided by the square feet. And so when I found the slope, I've really just found the cost per square foot. All right, so I need to rewrite that slope and say, well, that tells me that my cost for building this house is $150 per square foot. And that's it. Hopefully you did okay with that. So this next example, what I want you to do also is pause the video and try to figure out what's going on in this graph by calculating the slope and then looking at the axes labels and trying to interpret what the heck is going on in this graph. Okay, this is a graph that you've seen before in the last video, but I'm going to remind you about it because it turns out that EQAO wants to ask you lots and lots of questions about distance time graphs, such as this one. So we're going to not just leave it at this, we're going to look at some other examples of distance time graphs, and you're going to learn about how to interpret what is going on in the graph. All right, so let's start off by just simply calculating the slope. I'm going to use, again, some really nice, simple values. I'm going to use 0 and 1, and my run, it looks like, is 1 unit long, and my rise is 100 units high. And again, this is a positive slope. So if I calculate my slope, okay, that's rise over run, or 100 divided by 1, which I don't have to keep as a fraction. Normally, if the denominator is a number other than 1, then I want to keep that as a fraction. But I'm going to keep that as 100. Right? So, well, what does that really mean? Well, all I need to know to interpret what this means is to look at my axes. So I'm looking at the distance, or the kilometers per hour. So this really means 100 kilometers per hour. Well, what do we measure in kilometers per hour? Well, we measure speed. So it turns out that by calculating the slope of a distance time graph, that I've actually figured out the speed of the moving object. All right, so let's take a look at another distance time graph here. So I have a flat horizontal line. So without doing any calculations, I know that my slope is 0, just because it's just a flat line, right? So there are different ways that I can think about what this means. We looked at the last graph and we saw that a distance time graph means when I find the slope, I'm finding the kilometers per hour. So 0 kilometers per hour is what this horizontal line really means. So what does that mean if your speed is 0? If your speed is 0, to me that means that you're not moving. So if you guessed right, good for you. All right, so another way to think about this is this person is at 200 kilometers away from wherever 0 is, right? So they ended up 200 kilometers away from their starting point, and they just kind of stayed there for 5 hours, right? So that's just a second way to think about the motion described in that graph. So here's another distance time graph, and I want you to just take a minute to think about the slope of this line might mean, or what the motion, what's going on in this graph. All right, so I'm going to take you through this, and only you really know if you understood this or not, but you're going to have an assignment on this, so I'm hoping that you're paying attention and trying to make some good guesses. So I'm looking at my axes and it says distance from home in kilometers and versus time, right? So I know that the slope of the line is again describing the speed here, right? So, but if I wanted to write a little story or I wanted to describe what was happening, right, I could talk about the speed, right? So I would look at my speed as being the rise over the run. So I can draw my slope triangle wherever I want. If you find points that are closer together, then you find that you don't have to reduce your fractions. And so here I see that on my horizontal axis, my run is simply 1 because I'm going up by 1 unit. But it's not the same on my vertical axis. I can see that each tick mark is representing an increase of 50 kilometers. So that tells me that between 150 and 200, that this person has traveled 50. So my slope is 50 kilometers per hour in this case. But I should also talk about the fact that this is a line with a negative slope, right? So here's my line with its negative slope. To me, what this is saying, if the graph label says distance from home, then to me, 0 is where home is, right? So it looks to me like they traveled 250 kilometers, they started 250 kilometers from home. Okay, that's the first part. I would also say at a speed of 50 kilometers an hour. Okay, how long? Well, for 5 hours, and I know that because this is where they stopped, right? So, and where did they get? Well, they got back home. So started 250 kilometers from home at a speed of 50 kilometers per hour for 5 hours, and arrived home. Right, so some other things we could have seen the graph stop. Instead of going all the way to 5 hours, maybe they stopped at 4 hours. So in that case, they ended up not at home, but 50 kilometers, or 50 kilometers away from home. Hope that you understood that. If not, ask for some clarification, please. Okay, so this graph is a little bit more complicated than the other one. It's also a distance time graph. So when I look at this, I can describe sort of generally what's going on in terms of the motion, but then I can also calculate the slope if the question asks for it, right? So we've looked at slope quite a bit, and we know that the steeper the line, the faster that they must be going, right? So I can tell that in the first 2 seconds, this person travels a distance of 10 meters, right? So 10 meters in 2 seconds is the same as 5 meters in 1 second, so 5 meters per second. Then this next section of the graph, they're definitely moving faster. So I could draw 2 different slope triangles, right, between here and here, and then another second one here, because they're going at different speeds. The slopes of those lines are not the same. So what I could discuss was the fact that they started off, let's say maybe at home, and they traveled 10 meters away from home at a speed of 5 meters per second. Where am I getting that from? Well, it's 10 meters in 2 seconds, so that gives me 5 meters per second. In this second section right over here, okay, again, they're going in 2 seconds, they're going a distance of, well, I start at 10 and I go up to 30, so that's 20 meters, right? So 20 meters in 2 seconds, right, gives me a slope of 10 meters per second. So I was right. They're definitely going faster in the second part of this graph. And then what's happening? Well, it looks like they must have got tired because in the last section right here, they just stopped. Right? I can tell that because my slope value is 0. So hopefully you're doing okay with our slope calculations here. So when I look at this, I'm going to say, all right, I'm not going to go through the math of this. I'm just going to explain what it looks like is happening. It looks like they started a little bit after 0, so maybe it took them some time to get ready from the time they started sort of discussing things. So maybe, for instance, you know, you said you're going to leave at a certain time, but you'll end up leaving like maybe a few minutes after. Then you went a distance in miles, in fact 15 miles. And then you stopped for a while, for a few hours. And then what did you do next? Well, it looks like you kind of moseyed on home again. If I asked you where they were traveling faster, well, definitely this is a steeper slope, so they were traveling faster at the beginning when they were traveling away from their starting point, and then a little bit more slowly at the end. Again, if you have any questions, make sure that you ask me about this. You'll be getting a worksheet on this so that you can practice these skills. Make sure that you hand it in because I'll be looking at it to make sure you're on the right track.